Hello students, welcome to Marvel classes. In this video I am going to explain concept of matrices. First concept, types of matrix, definition of a matrix and order of a matrix. Matrix definition, a matrix is an ordered rectangular array of numbers. Ordered rectangular array of numbers or functions. Either numbers or functions. The numbers or functions are called elements or entries of the matrix. Either elements or entries of the matrix. Notation of the matrix is capital letters A, B, C, like that. Okay. So these three examples for this is an entry. Element is a real number, element is a complex number, and element is a functions. These numbers may be either real or complex, and functions you can substitute any function. Okay. So this is a definition of a matrix. A matrix is an ordered rectangular array of numbers or functions arranged in rows and columns. And notation for matrix is capital letters, and few examples for matrix. Matrix with elements are real numbers, elements are complex numbers, elements are functions. Next definition, order of a matrix. And matrix having rows and columns, m rows and n columns is called m by n matrix, is called m by n matrix, or simply this is m by n, read it as m by n, where first letter denotes number of rows and second letter denotes n denotes number of columns. Here this is an example. Here 2 rows are there but 3 columns are there, and hence it is 2 by 3. Order of the matrix A is 2 by 3, whereas order of B is 3 rows and 3 columns. So what is the definition of a matrix? Order of a matrix definition, number of rows and columns of a matrix is called order of a matrix and is denoted by m by n, where m denotes number of rows and second letter n denotes number of columns. And number of elements in a matrix. Here it has, the order is 2 by 3, therefore total element 2 into 3, 6 elements are there. Here order is 3 by 3 and total number of element is 9 elements. So in general, a matrix of order m by n has mn elements, m into n elements, number of elements in a matrix. Third, general form of a matrix. The general form of a matrix of order m by n, order m by n. Here A11 denotes the place of an element which plays in the first row and first column, A11, A12, A13, and this is general column, A1j, A1n. And the second row, A21, A22, A23, A2j and A2n, and this is general row, this is general column. And AI1, AI2, AI3, Aij, Ain, and last row AM1, AM2, AM3, AMj and AMn of order m by n. Here this denotes columns and this denotes rows, and total number of element is m into n, and number of rows is m and number of columns. Number of rows 1, 2, 3 up to m, number of columns up to n. So order of them. This is a general form of a matrix. Simply you can write Aij of order m by n, where I ranges from 1 to m and j ranges from 1 to n, and I and j are natural numbers. And examples for 2 by 2 matrix, A11, A12, A21, A22, this is a general form for 2 by 2 matrix, and general form for 3 by 3 matrix. General form for 3 by 3 matrix. So far we discussed 3 concepts. One is definition of a matrix, notation and examples, and second one is order of a matrix, and third one is general form of a matrix. Now next topic, types of a matrix. First type, singleton matrix. Singleton matrix. A matrix is said to be singleton if it has only one element. Only one element. For example, this is a matrix A contains only -5 and it is a order 1 by 1, and it contains only one function, so 1 by 1 matrix. A matrix which has only one element is called singleton matrix, and order is either 1 by 1 or simply 1. So first matrix. Second type, row matrix or row vector. A matrix is said to be row matrix if it has only one row. This is an example for row matrix which has only one row, and this is an B equal to, this is 1 by 1 and this is 1 by 3 and C equal to 3, C equal to 3 minus 5. This is 1 by 2. This order of this matrix is 1 by 3 and this is 1 by 1, this is 1 by 2. Very important remark about this matrix. Number of rows in a row matrix is 1 by 1 and number of columns, here 3 columns, here 1 column, here 2 column, and hence number of elements, number of rows in a row matrix is 1, but number of columns can be any number of column. Okay, so this is a general notation for row matrix. Aij of order 1 by n. Aij of order 1 by n. 1 denotes only one row and n denotes any number of columns or n columns. Okay, and the third type, column matrix or column vector. A matrix is said to be column matrix if it has only one column. Example A, 2 minus 1, this is 2 by 1 and this is minus 2, 5, 10, 3 by 1 and this is 1 by 1. See, if you check the second value, all are 1, because for column matrix, say every matrix should contain only one column. And what about number of rows in a column matrix? Number of rows in a column matrix can be any value and hence its general value is n by 1. 1 denotes column and this is row. Number of rows can be any value, but column is always 1. This is a third type, column matrix or column vector. And a fourth type, square matrix. A matrix in which number of rows are equal to number of columns is said to be square matrix. That is same number of rows and columns, same number of rows and columns. M by n matrix is said to be square matrix only when m equal to n and is denoted by square matrix of order n. So here 2 rows and 2 columns, 3 rows and 3 columns, 1 row and 1 column. And what is the general form of a square matrix? Aij of order n by n. Aij of order n by n. This is an example for square matrix. Square matrix means same number of rows and columns. Okay. And one additional condition, concept in square matrix, that concept is called diagonal elements, main diagonal, leading diagonal and principal diagonal. A square matrix, in a square matrix, set of element from left top to right bottom, this left top to right bottom constitute the diagonal of the matrix. This diagonal is called main diagonal, leading diagonal or principal diagonal. And one additional important concept here, trace of a square matrix. Trace of a square matrix is nothing but sum of all diagonal elements. Sum of all diagonal elements. But diagonal elements is possible only for square matrix. Why? Any idea? Yes, diagonal is possible only for square matrices and hence a diagonal trace is possible only for square matrix. And the fifth type, rectangular matrix. A matrix in which number of rows are unequal to number of columns. Rows and columns are different. Previous type, same number of rows and columns, but this type, different number of rows and columns. Here 2 rows and 3 columns, here 1 row and 2 columns, here 3 rows and 2 columns. A matrix is said to be rectangular if it has different number of rows and columns. Zero matrix or null matrix. A matrix is said to be zero matrix or null matrix if all the elements are 0. All the elements of the matrix are 0 and is denoted by capital O. Here this is zero matrix of order 1 by 1, zero matrix of order 2 by 1, zero matrix of order 2 by 3. But all the 3 matrices denoted by the same alphabet capital O, capital O, capital O. And hence very important note, what is the order of the zero matrix? Order of zero matrix. Zero matrix can be any order. Any order. Reason is, it may be, this is also O, 0, 0, 0, 0, 0, 2 by 2. It may be a rectangular matrix or it may be a square matrix, but both the matrices are denoted by the same alphabet, capital O, and hence 0 matrix can be any order. It may be a square or rectangular. Seventh type, upper triangular matrix. A square matrix in which all the elements below the diagonal elements are 0. All the elements below the diagonal elements are 0. This is 2, 2, 6 are diagonal elements. Below the diagonal elements, these three numbers are 0. Then it is called upper triangular matrix. A square matrix is said to be upper triangular matrix if all elements below the diagonal elements are 0, or you can write like this: a square matrix A equal to Aij is said to be upper triangular, Aij equal to 0 for I greater than j. For example, if I write a general form of 3 by 3 matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. See, what is the relation between these two numbers? First number is greater than second number, that is I is greater than j, I is greater than j. A square matrix Aij equal to is said to be upper triangular matrix if Aij equal to 0 for all I greater than j. So this is an example for upper triangular matrix. The next type, I less than j. Next type, in the next screen you have I less than j. If we consider these three elements, the first number is always less than second number. So next type, a square matrix is said to be lower triangular matrix. All the elements above the diagonal elements are 0. Above the diagonal elements are 0. That is Aij equal to 0 for all I less than j. See here, I less than j, 1 less than 2, 1 less than 3, 2 less than 3. Above the diagonal elements are 0. It's called lower triangular matrix. Lower triangular matrix means above the diagonal 0. Upper triangular means below the diagonal elements are 0. And there I greater than j, here I less than j. This is 8th type. Now 9th type, diagonal matrix or triangular matrix. A square matrix, all of whose element except those in leading diagonals are 0, is called a diagonal matrix. That is, all non-diagonal elements are 0. See here, these three are diagonal elements. Other than these three numbers, all other numbers are 0. This one and this one, this group. So below the diagonal 0, it is upper triangular matrix. Above the diagonal 0, lower triangular matrix. If you combine upper triangular and lower triangular matrix, then the new matrix is called triangular matrix or diagonal matrix. All non-diagonal elements are 0. Okay. What about diagonal elements? Diagonal elements can be any value, but the only one condition is non-diagonal elements are 0. That is the definition of diagonal matrix or triangular matrix. Next, scalar matrix. A diagonal matrix is said to be scalar matrix if diagonal elements are equal. There only one condition. Here only one condition, Aij equal to 0. What is the meaning of this upper triangular matrix? See here, I greater than j, lower triangular matrix I less than j, but if you consider this I less than j and I greater than j, if we combine these two inequalities, which gives I not equal to j, which means all non-diagonal elements are 0. Meaning is all non-diagonal elements are 0. So only one condition for diagonal matrix, that condition is non-diagonal elements are 0. Whereas in scalar matrix, non-diagonal elements are 0, non-diagonal elements are 0 and the diagonal elements are equal. That's why it is 0 for all I not equal to j. When I equal to j means what? A11, A22, A33. Here for diagonal elements, both the numbers, both the suffix are same. So when I equal to j, it is k. So in this case, k equal to 4. So two conditions for scalar matrix. All non-diagonal elements are 0 and diagonal elements are equal. Diagonal elements are equal. And last type, unit or identity matrix. A square matrix in which elements in the diagonals are all 1. That is, all the diagonal elements are 1 and rest are all zeros. So here all the diagonal elements are 1 and non-diagonal elements are 0. So it has two conditions. Condition number 1, this denotes non-diagonal elements. Non-diagonal elements are 0 and this denotes diagonal. This is non-diagonal elements and this is diagonal elements. All the diagonal elements are 1. Previous case, all non-diagonal elements are 0, diagonal elements are equal. Equal means it may be 1, 2, 3, 4. But if that equal number is 1, then that matrix is called identity matrix and is denoted by capital letters IN, where N denotes order of the matrix. Here it is 2 by 2 or simply I2, and this is 3 by 3 or simply I3. So special symbol for identity matrix, capital I. So this is the first part of matrices concepts. In the next video, I will explain the operations of matrices. Thank you.